Good morning, good afternoon, or good evening, depending on when you're watching this. Now we're going to continue with this topic, but look at multiple angles. So we're going to begin with express 12 cos 2x plus 5 sin 2x in the form k cos 2x minus alpha. Now we approach this in exactly the same way. So we make them equal. 12 cos 2x plus 5 sin 2x equals k cos 2x minus alpha. Now, as I've stressed all the way along, the next thing the exam board want you to do is to do that expansion. So 12 cos 2x plus 5 sin 2x equals k cos 2x cos alpha plus k sin 2x sin alpha. You must do that expansion. The next thing you need to do is match these up. Here I've highlighted them as in all the other videos. Cos 2x, cos 2x. So k cos alpha equals 12. Here sin 2x, sin 2x, k sin alpha is equal to plus 5. We don't need the plus, we know it's positive. And then we work out k in exactly the same way as we have been doing. The next thing we have to do is to turn our attention to finding alpha. So k sin alpha over k cos alpha is equal to 5 over 12. Now in exactly the same way, I'm going to cross these off, that equals tan alpha. So tan alpha is equal to 5 over 12. Now we know it's in the first quadrant, they are all positive. Cosine is positive and the sine is positive and the tan is positive. So it's the first quadrant. We don't have any complication there. So alpha is equal to the inverse tan of 5 divided by 12. And if we plug, it's not an exact value, so we plug that into our calculator and we would get alpha is equal to 22.6. So we were given 12 cos 2x plus 5 sin 2x is equal to k cos 2x minus alpha. We worked out k is 13, so it's 13 cos 2x minus 22.6 degrees. Thank you. Okay, so let's do a second question. Let's look at expressing 5 cos 2x plus 12 sin 2x in the form k sin 2x plus alpha. So you have to be able to express it in any form that you're given. So let's begin in the usual way. Let's make them equal to one another. 5 cos 2x plus 12 sin 2x equals k sin 2x plus alpha. And as I've stressed all the way along, the next important step is to do that expansion. Now when we do that, look what happens here. It's a wee bit different. If we highlight the coefficient of cos 2x, it's 5. Then we go to look for cos 2x over here. Here it is over here. So the coefficient of cos 2x is 5. The coefficient of cos 2x here is plus k sin alpha. So we're matching these up. Looking at these coefficients, k sin alpha is equal to 5. And then let's look for sin 2x, sin 2x, sin 2x. I'm going to highlight the coefficient here of sin 2x, it's 12. And here, coefficient is k cos alpha. So k cos alpha is equal to 12. So be very careful in that step. Once you're here, however, it's exactly as it's been right from the very first one you did. You work out your value of k, then once you've got k, you then try to establish the value of alpha. And again, it's in exactly the same way as before. Alpha equals 22.6. So we were given 5 cos 2x, 5 cos 2x plus 12 sin 2x, and we were asked to put it in the form k sin 2x plus alpha. And we have the value of alpha, and we have the value of k, so that's 13 sin 2x plus 22.6 degrees. Thank you.